Did you ever have one of those projects that got just a little bit out of hand? I have. Hey everybody, I hope you're having a fantastic day. I have been asked several times, how many relays can I connect directly to one of these mega boards without blowing the thing up? Well, I am about to find out. Now, before I get started, I want to say that although I've hooked a fair number of relays directly to Arduinos without problems and ran them for years, my favorite way of doing it, and the way that you should do it, is by using external power on the relay boards. Now, my favorite way to accomplish that is to take an old USB cable. This is an old micro USB cable, and I took the power and ground lines of the USB cable. And what I like to do is find these cheap, this is a Samsung clone charger, and I actually use one of these to power the relay board and use the other one with the USB cable to power the Arduino. Now, that being said, I don't think we're going to get to the point where I have to multiplex relays, but we are going to find out exactly how many I can hook up without crashing the thing and without burning it out. Let's get started. So, I've written a few torture tests to put both the Arduino and these relays through their paces, and I'm looking for the Arduino to either reboot or looking for these things to not trigger reliably or to skits out. But before I do that, I wanted to figure out exactly at what phase is the Arduino using the most power. Now, that may seem obvious that when I write these pins high, it would be, but that's probably not the case because these relays trigger when I write the voltage low on the pins. And so, when I write the voltage low, the LED comes on. So my hypothesis is that this thing is actually probably using more power when the Arduino pins are written low than when they're written high. So I've written a simple sketch to test this. I am writing all of these pins low for 5 seconds, and you'll be able to tell that because the LEDs will be on. And then I'm writing them high for 5 seconds, and the LEDs will be off. And we're going to get an idea of how much current is being used, and it's just going to loop through that. So let's hook it up. So it looks like we are using about 400 milliamps with all these relays triggered and about 90 milliamps with them all off. So that is a gigantic difference. We're using more than 4 times the current with them triggered versus not. So let's start torture testing. So just for simplicity, we are going to start using the terms on and off. On will be representative of writing these things low, and off will be turning them off, writing them high. So I've written my torture test, and what it's going to do is it's going to boot up. It's going to set all these pins as outputs, and then we are going to turn all the relays off. Then we're going to turn each relay individually on, off, on, off. Then we're going to turn them all on for 2 seconds and then off for 2 seconds. And we are looking for any sign that something is skitzing out. So right now, as you can see, we're getting nice clean clicks. We're not getting any kind of jumpiness. You can see a little bit that the LEDs dim here when they're all turned on and off, but otherwise, we're getting nice clean clicks, and it seems to be operating very well. Okay, here we go. 24 relays. I am guessing there's about a 1% chance that this is going to work. And I'm sure some of this would depend on how much of a load you had on these relays and how snappy you needed them to be. But let's give it a shot. Here's the test. That was clean. They all go through pretty cleanly. 32 relays. Contact. So as you can see, while all 32 relays worked individually, we did not have enough power to trigger them all on at the same time. Now, some of that could be due to some losses in the breadboard, but I'm guessing we've just hit the limit. Stick around to the end of the video, and I'm going to attempt to hook a relay up to every single GPIO pin on this board, both analog and digital. But in the meantime, there are a few conclusions that we can draw. The first one is that although it's not advisable, you can hook an 8-channel relay up to the Arduino, power it with the Arduino, and trigger the relays on and off in any combination you want. It will work. The second thing that we've learned is that intermittently, you can connect up to a total of 4 of these boards. You can't power them all on at the same time, but you can intermittently use some relays if you want to. Now, that is not advisable. So the question is, what is advisable? And that is to use external power. But there's conflicting information on the internet, so I want to show what I've learned. The first thing is that when you look at this relay board, you will see that there is a jumper here that is inconveniently labeled JDD-VCC, and that jumper is connected. Now, you might think that by moving this jumper over to this side, you would get some different mode, but you do not want to do that. What you want to do is you want to completely remove this jumper. And the way this works is that you will connect the ground of your external power supply to this side. You'll connect your voltage, your 5 volts of your external power supply to this side. And this doesn't make a whole lot of sense, at least it's not obvious, but you will also connect the VCC on this side directly to your Arduino. And you absolutely do not want to connect the ground on this side to your Arduino. In fact, you might want to store the jumper there so you remember not to connect it. But so that's ground to your power supply, VCC to your power supply, VCC to your Arduino, and no connection here. And what that will do is that will both allow you to power this externally so that you're not drawing too much power off the Arduino, and it will allow you to properly isolate this relay board from your Arduino. So how do I do that? My favorite way is to take an old USB cable, the higher quality the better, and I cut the ends off and strip back and get the red and the black to be my hot and my ground. And this hot and ground will go to the VCC and the ground over here on the relay. Next, I will connect the VCC from the relay to a 5-volt pin on the Arduino, and that is my connection between the two. But how do I power it? I love using these Samsung style dual USB chargers. And so what I do, I make sure that I have at least 500 milliamps for every single one of these relay boards that I'm trying to power up. So if I'm going to power up 4 of them, I want to make sure that I have a 2-amp charger to support this. Ideally, though, I generally use one little USB charger per relay bank just for the heck of it. So what I like to do is plug the relay into the charger, and then I use the second port of the charger to power the Arduino. So now we have a nice, neat package that gives you electrical isolation and powers your relay bank and powers the Arduino. That is how I like to do it in the field. Okay, here are 72 relays. 68 of them are hooked up. I am using every digital output pin as well as every analog pin on the Arduino. No multiplexing, I'm not going there, but let's see what happens. You're seeing this for the first time just like I am. Oh, goodness. That's a lot of snapping. Wow. 4 amps of current, 68 relays, 1 Arduino. If there's any jank, I would blame it on my wiring or the relay, but not the actual Arduino itself. There you have it, ladies and gentlemen. 68 relays, 1 Arduino, very loud snap.